Let's try and understand inductance of solenoid. Okay, this is a solenoid. It's a metal tube, current carrying coil wound around it. All right. Now this is the direction of current in which it's flowing, I, and this is the length of the solenoid, and this is the diameter of solenoid. And we already have seen that capital N is number of turns, small n is number of turns per unit length. So it is capital N upon L. So capital N is equal to NL. All right. Now B is equal to mu 0 Ni. This we had seen in Ampere's loop law. All right. Now flux is directly proportional to current. So when we are talking in terms of inductance, when the proportionality goes, a proportionality constant L, that is inductance, comes into picture. So flux is equal to Li, and if there are n number of turns, then the formula gets n phi is equal to Li. All right. Okay, so L is equal to n phi over I, and this also is equal to, we already saw that n phi. So n phi, we know that B is equal to flux over area. What would flux be? Flux is equal to B into A. We just substitute in place of flux BA. So NBA upon I. Now, we also know that B is equal to mu 0 Ni. So instead of B, we substitute the Ampere's loop law. All right. So what happens ultimately? So that's what I've written here. B is equal to mu 0 Ni, which we substitute over here. So ultimately what happens is this gets cancelled. Let's recap this part again. L is equal to n phi over I we took down. Then B is equal to flux over area. So flux is equal to B into A. So instead of flux, we substituted B into A. Then we also know that B is equal to mu 0 Ni. So we substituted there mu 0 Ni into A. Now in denominator we have I. So I gets cancelled. And again here small n, which is number of turns of coil per unit length. So we are to substitute capital N. So capital N would be small n into L. So that's what we do. We substitute over here. I gets cancelled. So the basic formula for inductance in terms of solenoid with coil winded around it with N, capital N number of turns and small n number of turns per unit length. That's what we are talking over here, number of turns per unit length. So inductance is equal to mu 0 into small n square. Small n is number of turns per unit length square into length into area. So this becomes our formula for inductance. So inductance per unit length near middle of long solenoid, what would that formula be? So what we would do is we would take this L down there. So that becomes L over L. That is, this L is inductance and this L is length. So inductance per unit length near middle of long solenoid would be this formula. All right. Now this formula, we know A, area is pi r square. We substitute that. And if it is diameter which is given, so it has to be diameter divided by 2 is radius. So d square, since it's r square, so it gets d square upon 4. So this becomes the formula. So again, this as well as this, these two formulae also you have got to have it in mind for your numericals. All right. So there are lots of substitutions, lots of formulas. So you have got to be well versed with these formulae. Okay. Now again, talking about inductance in series, inductance of series, total L total is equal to L1 plus L2 plus L3, which is in series combination, and for parallel it is 1 over L1 plus 1 over L2 plus 1 over L3, which is for parallel combination. Now this you have just got to keep in mind is it's as good as resistance. All right. Okay.